Right, we're now going to have a look at another Hess's law question. This one differs from the previous one because the previous ones, the data we were given was the standard enthalpy change of formations. We're now going to be given the standard enthalpy change of combustion. So the data here that's given to us is the standard enthalpy change of combustion for these elements and compounds. Okay, the question is asking us to calculate the enthalpy change of formation of ethanol, which is C2H5OH. The first thing you need to do to construct your Hess cycle is write down the equation for the enthalpy change of formation of ethanol. Okay, they haven't given that to us here, so that's the first thing we need to do. The definition of a standard enthalpy change of formation includes the fact that you have to form 1 mole of the compound from its elements. So we have to make 1 mole of ethanol. So in our equation, we have to make 1 mole of ethanol in its standard state, which is liquid, and we have to form it from its elements in their standard state. So this is made up of carbon, hydrogen, and oxygen. So it's carbon in the solid state, hydrogen, which is diatomic, so it's H2 and it's a gas, and oxygen as well, which is diatomic and a gas. And now we've got to balance it, ensuring that we're only forming 1 mole of ethanol. So to do that, we need to have 2 carbons here. We've got 6 carbons on this side, so we need to have 3 hydrogen molecules here. And we've only got 1 oxygen on this side, so that means we only need half an O2 molecule here. Okay, so this is the one that we're being asked to work out. So we're being asked to calculate the enthalpy change of formation of ethanol. This is the X, this is the one that we don't know. Now, to construct our Hess cycle here, we have to look at the information given to us. So we've been given the enthalpy change of combustion of these various elements and compounds. So if we're given the enthalpy change of combustion at the bottom of our Hess cycle, we have to write combustion products. Okay, you literally just have to write combustion products at the bottom. And now all of your arrows, because we're burning all of our arrows have to go from those elements and compounds to the combustion product. So all your arrows here need to be pointing downwards. Okay, I'm not going to do an arrow pointing downwards for oxygen. Oxygen is the only substance that you can't burn. Okay, the reason being is because if you just react oxygen, remember when you burn anything, you're just reacting with oxygen. Oxygen reacting with oxygen doesn't do anything. Okay, so the only one that you never have an arrow for in this sort of Hess cycle is oxygen. Okay, because that's just going to be a value of 0. So all my arrows are pointing downwards. That is going towards the combustion products there. And now all we do is we put in the values. Okay, so these are all to burn 1 mole of the substance. If I've got 2 carbons, I've got to do 2 lots of -394. I'm burning 3 moles of hydrogen, so it's 3 lots of -286. And over here we're just burning 1 mole of ethanol, so that's -1367. Okay, now as before, because we can't do this direct route here, so this is the direct route we're trying to work out, we're going to go via the indirect route. Okay, so we're going to go from our reactants via our combustion products to our actual product over here. Okay, so first thing we need to go from our reactants down to the combustion products. We're going to follow this red arrow. We're going in the same direction of these 2 arrows over here, so the sign of these stays the same. Okay, so all I'm going to do is just take the minus sign out of the bracket. So minus, so this is what I type into my calculator, minus 2 lots of 394. And then again, going down this arrow, sign stays the same. I'm just going to take the sign out of the bracket. So minus 3286. Okay, so we're now at our combustion products. We want to go from our combustion products to our actual products. So we're now going to go in the opposite direction of this purple arrow here. So that means we have to change the sign of this. So that's going to become plus 1367. If I plug that all into my calculator, I get a value of minus 279 kilojoules per mole. Okay, so that means this root over here equals minus 279 kilojoules per mole. According to Hess's law, if the starting and final conditions are the same, this root here also equals this root x over here, and that means this value, this arrow here, is also worth minus 279 kilojoules per mole, and therefore the enthalpy change of formation of ethanol is also minus 279 kilojoules per mole.